My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 362. In this lecture, we will try to understand gradient descent algorithm and its geometric intuition. So, when we learning about maxima and minima, we saw examples where solving df by dx equal to 0, isn't it? This is df by dx equal 0, or I can say vector sense. In vector sense, I can write it as del f with respect to x equal to 0. Solving this equation is not straightforward. Solving is difficult, isn't it? Finding solution for this is not straightforward, because solving this equation df by dx equal 0 could be tricky, where we said that solving this equation is not easy. When solving these equations are not easy, we have an alternative. The alternative is called, what is that alternative? Gradient descent algorithm. What is this gradient descent algorithm? We will try to understand. A gradient descent algorithm is an iterative algorithm. It's an iterative algorithm. It is an iterative algorithm. This gradient descent algorithm is an iterative algorithm. It's an iterative algorithm which is very easy to implement in modern computer, and it works like this. First, we make a guess of what is our x. We will guess this, what is our x is. Pick a random number. As a random number, let me say x naught, isn't it? Yes, let me assume x naught. This is your first guess. We would like to find x star. Its first guess is x naught, isn't it? Because the problem that we are trying to solve here is x star equal to argmin of f of x over x, isn't it? So first it guesses whether the random value guesses the random value x naught. Then using this gradient descent algorithm, now it will move to new value of x1. Then it will go to x2. I can say, what is the procedure? My x naught is first guess. This x naught is first guess of what? Of x star, isn't it? x1. This x1 is iteration number 1. In x1 I can find x2. x2 means iteration number 2, isn't it? So on xk, I can say iteration k, isn't it? Yes, which is very close to, just I must find x0, x1, x2, so on xk. This xk which is very close to x star. Objective in this iterative algorithm is, as your iteration number increases, you have to move closer and closer to x star, isn't it? This is optimal solution. This is your objective. Objective is, as your iteration number increases, you have to move closer and closer to your x star. Now let's see how it works. Let's understand gradient descent geometrically first. Let's take a simple example. Let me take one simple example here. Just see this one. Yes, this is simple. Let's take a simple example. This is let's assume I have a curve like this. So for this curve, I want to find what we have to find. Here we have to find We have to find which one we have to find. We have to find x star. We have to find x star. We would like to find x star, isn't it? What is my x star? X star equal to argmin of f of x over x, isn't it? This is what I want to find. Imagine if I want to find maxima, always remember, if you want to minimize that function, min of f of x is equivalent to, what is minimum of f of x in optimization? Your x star is argmin of f of x. Minimum of f of x is maximum of minus f of x. This is very simple rule in optimization. Or maximization of f of x is equal to some, you can write it as minimum of minus f of x. So if you learn for minima, you can do same thing for maxima, isn't it? By just changing the sign of the function. If you know the minima, you can just by changing the sign, you can convert maxima of f of x is minimum of minus f of x. Minimum of f of x is maximum of minus f of x. So if you know how to find maxima and minima, you can always calculate other one. This is basically maximum of f of x equal to minimum of minus f of x. It is easy to find other thing. That's what it says. Hence, let's study for minima. If you see visually, what is this? What is this particular point? This point, what is this? This point is minima because every other point value is greater than this value of f of x. Isn't it? F of x is greater at every other point except at origin. So now let's go to the core idea. Core geometrical intuition. The core geometrical intuition of gradient descent geometry works like this. Let's take a point here. This is my point in this one. Just see this one. Its gradient is just, if I take, let me consider this one. Yes. If I take a point here, what I have to do? Its gradient is positive slope, isn't it? What is the gradient? If I take tangent, if I consider this theta is between 0 and 90. 0 less than, theta less than 90. Therefore, tan theta, it is a positive value. What is the slope here? Slope is here. The slope at this slope is negative. Why? Because this is positive slope. Here it is this slope here is 0, isn't it? The slope on one side of minimum, isn't it? On one side of minimum is positive. Here what happens, just if you observe here, this, if you consider this point, this is the tangent. What is the tan theta here? Tan theta is negative, isn't it? Why? Because here this you can see the angle here, isn't it? Because of this theta with respect to x-axis, we already discussed all these things, where it is positive, where it is negative in my previous lectures. This I discussed, this also I discussed, isn't it? Therefore, let me repeat, its gradient is positive slope, isn't it? The theta lies between, why it is positive? Theta lies between 0 and 90. This is positive value. What is the slope here? Slope at minima. What is the slope here? This is minima, isn't it? What is the slope at minima? Is 0. The slope on one side of minima is positive. Let's look at other side of minima. What is the slope here? Just we will try to understand slope here. The slope here is negative, isn't it? What is the angle with x-axis? This theta is the angle with x-axis. Theta is greater than 90. I can say theta is less than 90 is less than, I can say 90 less than, theta less than 180. This theta lies, I can say, and theta is greater than 90. That's important, and less than 180. So what happens is, around minima on one side, the slope is here positive. Here you will get positive. Here on left hand side of minima, you will get negative slope, isn't it? On the other side of the slope is negative. This side is slope is negative, this side is negative, this side is positive, this is 0, isn't it? Exactly at minima, the slope, this is the minima, exactly at the minima, slope becomes 0, which means slope changes, isn't it? Slope changes its sign from positive to negative at minima. Here it is positive, here it is negative. This is very important observation. The other important observation is, imagine, this is, let me say, yes, one side of slope is positive and other side is negative, isn't it? At minima, slope is 0. Yes. Consider this. Imagine this is my plot. This is my plot, isn't it? If you have a point here, so you have a slope here. Let this slope is S1. S1 is slope. Let this slope and another point here. You have slope is S2, isn't it? As you move closer to X star, this is X star, isn't it? This is my point, minimum point. As this is X naught is initial approximation. As we move towards your X star, what happens? As you move closer to X star, this is X star. As you move closer to X star, your slope reduces, isn't it? If you are coming from X naught to X star, this is my X star origin, isn't it? That's the minimum value. If you are coming from X naught to X star, if you are coming from this side, the slope, what happens? The slope decreases. Slope decreases. Here you have high slope, here it's low slope. Slope decreases, isn't it? Here, yes. Here what happens? Just see. Slope here, what happened? This is slope is negative, isn't it? Slope here is negative value, because what is happening as you are going from one side to other side, you are going from positive value to negative value. If you are going from this side to this side, let me say like this, it is simple and straightforward. If I move from here to here, what happens? Slope decreases. From here to here, slope increases. Here it's a decreasing slope. This is slope is 0, negative. Isn't it? Yes. Using these simple observations in geometry, let's go and understand how does gradient descent works. How does your gradient descent algorithm works? We will try to understand in my next lecture, that is in lecture number 363. Time being, just understand, if I move from x0 to x1, your slope, what happens? Your slope decreases. If I move from here like this, slope will increase, isn't it? Just you can always understand this one. Anyway, I will discuss in detailed manner about this particular concept in my next lecture. Just it's a matter of finding tangents. You know how to find slope, isn't it? Just refer my previous lectures. Thank you very much.